Let's take a look at systems of linear equations, two variables by graphing on a T89 calculator. Now this is www.mathheals.com, and if you go to the graphing calculators link, you'll find more links to YouTube videos. I'll go into college algebra, and these are all the different topics that you can use the graphing calculator with. And I'm going through and creating these for all the different models of calculators, so you'll eventually see all of them appear, or as many as I can. If you need help in a particular topic, you can go to math class information. I'll probably change that to math lectures here shortly. And then you go into college algebra, and you can watch, like for example, if you're having trouble with quadratic equations, you can watch the YouTube video. This is the exact same lecture I give in the classroom, same explanations, same examples. Don't watch WebEx. Those were before I learned how to do YouTube. Okay. Well, let's look at this problem here. So we've got y is equal to 3x minus 3, and y is equal to 5x minus 7. This method works out fairly well if you got y by itself. Though we're going to see with our second example, it's not perfect. So there's a little bit of a problem with it. Okay, well, if I, let's see, I'm going to enter those in. So I do diamond F1, and I'll put 3x minus 3 on y1. So 3x minus 3, press enter. And on y2, I'm going to put 5x minus 7. So do 5x minus 7, enter. Now I want to graph. So I do diamond F3. Now there's our first one, and there's our second one. And where they intersect is our answer. Normally, in college algebra, if you're solving this by graphing, you just look at it and see your answer. Sometimes that's not so easy to see, though. Well, a calculator to help us. See, there's an F5 math in the menu across here. So I do F5. And when that pops down, I want to choose intersection. So I choose the 5 that's in front of it to choose intersection. I'll do enter our first curve, enter our second curve. Now our lower bound. Our intersection is right here, and we want a cursor to the left in terms of the x values of the intersection. Well, that's to the left of it. So I'll go ahead and press enter. We don't want it too far away, but you don't want it too close either. Now upper bound, we want it to the right of it. So I'm going to do my right arrow key, and I'll put that right up there. And I can see in terms of my x values that the cursor now is to the right of it. And press enter. And that comes back and tell us our answer is 2, 3. Well, let's take a look at our second example. Y is equal to 9x plus 1. And y is equal to 2x minus 3. We're going to find this one doesn't work as nice as the first example. I'm going to do diamond F1 to go back to y equals. Up arrow to y2, press clear. Up arrow to y1, press clear. And on y1, I'll put 9x plus 1. So 9, my x key, plus 1, enter. On y2, I'm going to put 2x minus 3. So 2x key minus 3, enter. Now I'm going to graph, so I do diamond F3. There's our first graph, and there's our second graph. So this right here is our answer, where they intersect. Well, I'm going to do F5 for math, and then I want to choose intersection. You see there's a 5 next to it, so I do 5. Enter our first curve, enter our second curve, and lower bound, we want to move our cursor to the left of where the intersection is. Intersection is right where my cursor is, or where my mouse is, and you see this is to the left of it, so that's fine. We'll press enter. Then for upper bound, we'll press our right arrow key and move it to the right. Here's where our intersection is, and that's definitely to the right of it in terms of x values, and press enter. Okay, and we got negative 0.57. So negative 0.57. And then we got negative 4.14. Okay. Now, those are in these variables, xc and yc. So if I write that down, this is going to be xc, and this is YC. We don't like approximations if we can help it, so we want exact values. So I'm going to exit out. I'll do a second escape to quit. Now, depending upon what your mode's set up as, if I choose mode, and then I do F2 for page 2. I changed mine to exact, but let me set it back to probably what yours is. So I down arrow to that line, I'm going to do a right arrow, and I'm going to choose 1 for auto. And then I'll do enter for save. Now if I type in XC, so I got X, and then I do alpha C, which is the closing parentheses, and now press enter. You see we get this decimal approximation. It did not change to a fraction, did it? I could force it to change to a fraction, but it's going to give us something weird. Let me show it. Now I can do this. The same thing will happen with YC. So if I press mode, do F2 for page 2, and down arrow to exact approximate, do a right arrow, and let me choose exact now. So I do 2, and press enter. And now if I do enter on XC, it tries to convert that to a fraction. That is not correct. It's taking the approximation and it's putting it over 1 and then a bunch of zeros. Isn't what you really want. Finding the intersection with this method is not a very good method compared to some other ones, and we'll discuss that here in a minute. I'm going to set this back, so I'm going to go to mode, do F2 for page 2, and for exact approximate, I'm going to do a right arrow, and I want to set it back to auto. So I do 1, and then I do enter to save that. Now if I do XC, you see it doesn't try to come up with that weird fraction. Okay, better way. Instead of doing it this manner, if I get all the variables on one side and then the numbers on the right side, so we're going to get the variable terms on the left side, I'm going to take the 9x and move it over, so it becomes a negative 9x plus y equals 1. And here I'll take the 2x and move it to the left side. It becomes a negative 2x plus y equals negative 3. We're going to write down a matrix that goes along with this. You drop the x's, y's, and equals. Keep the numbers in your signs. So we've got negative 9, 1, 1, negative 2, 1, negative 3. Now I want to enter this matrix in. Now I already, let me clear this, up arrow and do a backspace to clean all those out. I already have a matrix called A in my calculator. And if you want to see the full video on this, go watch the YouTube video on solving system equations, 2 equations and 2 variables by matrices. So I'm just going to go into my apps. I go into my data matrix editor, so I do 6. And I'm going to do an open. You might do new if you don't have A already defined. So I do 2 for open. I'm going to see it says data, so I'm going to right arrow, and then I want to choose matrix. So I do 2. Now down arrow, and if I do a right arrow here, this is all the matrices we have defined. I only have A. If you see nothing there, you have to do a new. And then I do enter on that, and enter again. Now our size of our matrix is already good, but if it wasn't, I would go into util. So F6, and I get to F6 by doing second F1. And then you choose 6 for a resize matrix. And it's rows by columns, so we'll do 2, down arrow, 3, down arrow, and then we enter to save it. Like I say, mine was already okay, but if yours wasn't, then you change it that way. Type in each number, do negative 9, enter, 1, enter, 1, enter, negative 2, enter, 1, enter, negative 3, enter. Okay, so I'm going to exit out, so do second escape. Now I want to do RREF. So I go to my math. So I do second, 5, bring up my math menu. I choose 4 for the matrix. And then I want to choose 4 for RREF. Now I need to tell it to REF of what, and I put my matrix in A. So I do alpha equals, and that'll put A, and I'll put a closing parentheses, and then enter. Now look what we came up with. Our answer is actually negative 4/7, comma, negative 29/7. You're going to find that if you use RAF, then you'll always get the exact answer. You won't get a decimal approximation like this. Now that's solving systems equations, two equations, two variables, on a T89 by graphing.